Hello everyone, it's me, Bill Younger again, and this time I'm going to go over Special Relativity 003. In this video, I'm going to discuss length contraction. I'm actually going to derive it with a very particular problem. So let me start off by sharing my screen so you can see the problem. So as you can see, it says a spaceship carrying a band of Bajorans is flying by Deep Space Nine, headed for a sneak attack on the Kardashians. No, not those Kardashians. The craft is flying by at a huge speed v, and the people on the space station are watching. Since those observers are on Deep Space Nine, the distance from Deep Space Nine to Cardassia is not moving with respect to them. Because of that, the distance is a proper length, and we shall assume it is a length L0. Part A. In terms of V and L0, how much time, delta T, do the Deep Space Nine inhabitants believe the trip will take the Bajorans? Note, since the beginning of the trip starts right in front of Deep Space Nine and the end is at a different location, the inhabitants do not measure the proper time. Hence, we call it delta T, not delta T0. So let's attack part B first. So I'm going to stop my share and I'm going to go to my document cam. So in part A, we're going to make use of the fact that this is problem, I think I called it problem 3, didn't I? Oh, great. I just erased the problem. Yes, I called it problem 3. So we're going to use the expression that velocity is equal to distance divided by time, and that's true whenever the velocity is a constant. In this case, the velocity we can assume is a constant because they didn't say anything else about it. So in this case, we're going to say delta t should be the distance traveled, delta x over v. Well, we were told to call the distance traveled since it's measured by us and not moving with respect to us on Deep Space Nine, we called it L0 for the proper length. And then, of course, that would be divided by the velocity of the spacecraft, v. Now, that was part A. In part B, we're actually wanting to do the same sort of calculation, but this time we're going to do it for what the perspective is from the ship. And in this case, we're going to, I'm actually stalling a little bit to open the problem that I just had. So we're going to go back and share screen once that becomes available because I accidentally closed it out. So we've now got this delta t. The next thing we're going to do is figure out how long it takes according to the Kardashians. So, or excuse me, according to the Bajorans who are traveling towards Cardassia. So in that case, we know that they're basically the front end of their ship is going to arrive at Deep Space Nine at the beginning of the journey, and then at the end of the journey, the front of their spacecraft will arrive at Cardassia. So both events actually took place right at the same spot in their coordinate system, specifically the bow of their ship. So they are actually measuring proper time. With that in mind, I should be able to share the problem again. So I'll share the screen. So now in part B, it says, those on the spacecraft see the front of their craft being alongside Deep Space Nine at the beginning of the journey, and then see the front of the ship being alongside Cardassia at the end of the journey. So they are measuring proper time. The events happened at the same place in their frame. What is the time they conclude the trip took? Let's call it delta t0, and we want to know it in terms of v and delta t. So I'm going to stop sharing again. And this part in part B, again, we're trying to find the proper time. And we know that delta t is equal to delta t 0 over the square root of 1 minus v over c squared, which is also equal to gamma times delta t 0, where gamma is defined to be 1 over the square root of 1 minus v over c quantity squared. So I will use gamma because that'll save us a lot of writing, as I actually hinted at in the problem. So I'm going to find out their time. Their time is delta t0, which should in fact be delta t over gamma. So with delta t over gamma, I now know how long their journey will be. If I can figure out this by dividing the distance from Deep Space Nine to Cardassia, dividing it by the velocity of the Bajoran ship, then I can take that time and divide it by gamma, which of course is related to v, and that will give me the time required. So this was the first answer, and this was answer to part B. So now let's look at the problem again, and this time we're going to look at part C. So now we're up to part C, and it says, let's call the distance the Bajorans travel L, since it is not the proper length, and compute it in terms of V and delta t 0. What is that distance? So we're looking for it in terms of V, and of course we call it L, and what we want to do is find that distance L. So let me stop sharing the screen, go back to the paper again. We're going to say L, which is not the proper length, because as you can tell, that distance is actually moving with respect to the Cardassian, or to respect to the Bajoran ship. And that too, just like velocity equals distance divided by time, distance is equal to velocity times time. So in this case, I want to take the distance L and say that's equal to the velocity of what the Bajoran ship sees, basically Cardassia and Deep Space Nine moving at it with. So, you know, and the Cardassian are in the Bajoran ship's frame, Cardassia and Deep Space Nine are moving, say, this way at exactly the same speed that we think the Bajoran ship is moving that way. So that is the V. And of course, they think it was V times delta t, which is the time they measured. So that's the delta t 0. So we have that. And now we have L in terms of V and delta t 0. Going back to the problem, let's look at part D. So use the answer to A and the answer to C to determine the relationship between L and L0. What is that equation? And it says, note, feel free to save some writing by using gamma once you have shown V in it once. So I already took care of that, of course. But now we're going to basically get L in terms of L0, removing the time, which we really didn't care that much about on this problem, because we're really trying to derive the relationship between a moving length and a non-moving length. So in part D, we're asked to use part A and part C. So we have A was that delta t is equal to L0 over V. And from part C, we have L is equal to V times delta t 0. But as you can tell from part B, delta t 0 is equal to delta t over gamma. So I can say, combining, let's call this 1, let's call this 2, let's call this 3. If I combine 2 and 3, then I will get L is equal to V times, now delta t 0 is delta t over gamma. Now, if I combine this equation, which I'm going to call this one 4, say, if I combine 4 and 1, then I can get L is equal to V over gamma times delta t, but delta t, as we saw from 1, was L0 over V. So you see that the actual V's will cancel out, top and bottom, and I'm just left with L0 over gamma. So the length contraction formula is in fact L is equal to L0 over gamma, which you can also write as the square root of 1 minus V over C squared times L0. And that's the formula for length contraction. Well, I hope that was clear to you, and I hope you found it helpful. Have a good day.